Today we are talking about transformations of the trig function graphs. So we're going to begin with a little bit of a review from what we did last time. We already learned about amplitude and about period. Those are the amplitude of the sine and cosine functions. That is a vertical dilation of those functions, and the period is a horizontal dilation. Stretches it out or scrunches it up one way or another. One new thing to know about period is frequency. Frequency is 1 over period, and that makes sense because the bigger period is, the less frequent things are going to be happening on the graph. The less frequent you'll have a max or a min, etc., or 0, whatever. Okay, so let's review amplitude and period. Okay, let's write an equation for the function whose graph is shown. So what I see when I look at this is I see that it goes to the origin, so I know we're dealing with a sine curve. I know this is going to be sine because it goes through the origin. Okay. Well, I should say one way to express this is to describe it with a sine function because it goes to the origin. Okay, and then this curve is starting up going in the positive direction, so I know that its lead coefficient on the sine is going to be positive because we start off going positive. Okay, and the amplitude here, it goes up to 0.5 and then down to negative 0.5, so I know the amplitude is a half. So far I have 1/2, positive 1/2 sine of, and now what is the period? Well, the period is pi over 2. One complete cycle is done in pi over 2 units. So the period is pi over 2. But I know that period is always the normal period for sine, which is 2 pi, divided by the coefficient on your x down here. And I'm going to call that b, be consistent, and call that b each time. So I'm going to take this and solve it for b. I'm going to cross multiply, and I get b times pi is 4 pi. Now divide both sides by pi, and we get that b is 4. So the coefficient on the x is 4. Okay, that means the horizontal dilation is a factor 1 over 4. The vertical dilation is a factor 1/2. Okay, so this would be our function f, an equation for f. Let's do another one. For this one I would probably call it a cosine because it's starting up high. Starting up high, I'm going to call this a cosine. It's not starting at the origin. Okay? And it does start high, so it's going to be a positive cosine, not a negative cosine. If it started down low and went up, it would be a negative cosine. This is a positive cosine. Okay? The amplitude is 3. So far I have 3 cosine. And now I just need to know what is the period. Well, the period, it repeats itself every 8 pi over 3 units. So the period is 8 pi over 3. But again, I know that that is the normal period for cosine divided by the coefficient for the x, that b. We're going to cross multiply, and I get 8 pi b is 6 pi. So b is, if I divide both sides by 8 pi, b is 3 over 4. So up here, this x coefficient is not 4 over 3, 3 over 4 x. So that is our equation for f of x. Okay? All right, let's do another one. Okay, I would probably call this a sine curve because it starts at the origin. Okay, the amplitude is 2. It's going up, so it's going to be a positive sine. Starts at the origin, goes up, so positive sine. Amplitude is 2. The period is 4. Period is 4. So to find b, I would take that 4 that I know the period is, take that 4 and set it equal to the normal period divided by b. Cross multiply, 4b is 2 pi, so b is pi over 2, and we divide both sides by 4. So this equation would be 2 sine of pi over 2 x. Okay, let's do another one here. Okay, this is another sine because it starts at the origin. However, it's going in the downward direction. So this is going to be a negative sine. The amplitude is 1, so it's just going to be negative sine of, okay, the period is 2, right? The period is 2. I set that equal to the normal period for sine divided by b. So 2b is 2 pi. That means b is pi. So this is pi x. Alrighty. Okay, let's sketch a graph. Let's sketch the graph of this function. So we're going to go backwards. Here I gave you the graph and told you to write the equation. Now I'm giving you the equation. You draw the graph. Okay, it's sine. It's sine. So when I think of sine, I think it starts at the origin. Okay, it's got a positive 2, so I know it goes up to 2, right? Goes up to 2, but my question is how big is the period? Let's find the period. So the period is always the normal period for sine divided by the coefficient on your x, and the coefficient on your x is pi over 2. That is the period. If I multiply both top and bottom by 2, I get 4 pi divided by pi, which is 4. So the period is 4. The period is 4. That means if I start at 0 here, at 4, I'm going to have another 0. So this is a sine curve, and I know that sine is also 0 halfway through its period. And then at its maximum, it's going to be 2. At its minimum, it's going to be negative 2. So here's one period. There's one period. Now, since they gave me the graph that extends, I must draw the graph as far to the right and left as I can. So I'm going to continue this pattern until I end the graph on the right side. And I'm going to continue the pattern until I end the graph on the left side. Oops. And there's the graph of that function. Okay. Let's sketch the graph of f of x is negative 3 sine of 1/4 x. Okay. So let's get the period. First of all, I know it's a sine. There's no horizontal dilation yet, or vertical dilation yet, so I'm going to start it at 0, because it's a sine. Since it's a negative 3, I know I'm going down, right? To start off with, I need to go down. But let's think about the period, that 1/4. The normal period for sine is 2 pi. We divide by the coefficient to get our period. This is the period. If I multiply top and bottom by 4, we get 8 pi. That means the period is 8 pi. That's the period. So I started at 0. After 8 pi units, I'm going to have finished one cycle. Halfway through for sine, I'm back to 0. Half of that, I'm at my, in this case, minimum. Because it's negative, I'll be at my minimum. Halfway on the other side, I'll be at my maximum. So one period for this function looks like that. Again, I want to continue it on both sides, so after 2 more pi's, I'll be down here. Okay, after 2 more pi's in this direction, I'll be up here and then back to 0. Like that. Okey-doke. Let's do a cosine. 2 cosine of 2x. Once again, let's find the period. So the normal period for cosine is 2 pi. I divide that by my coefficient to get my period. So the period is going to be pi for this function. The period is pi. Okay, cosine, positive coefficient. Starting at my origin, cosine starts up. After pi units, I'm back up. For cosine, halfway through, I'm at my least possible number. And then half of those, I'm at 0. So 1 period looks like this here. And now I just have to continue that pattern on the right and the left. So right, and left. Notice on these when I draw them that I don't put an arrow here, okay? And I encourage you not to put an arrow there. If you do, I will know what you mean. However, if you put an arrow here, it looks like it continues down, and it doesn't continue down. It continues making this wave, right? So I encourage you not to put arrows on these. Okay? Let's do one more of these. This time we have a -3 cosine of 1/2. So let's do our period. So the normal period for cosine is 2 pi. I divide by the x coefficient. If you multiply top and bottom by 2, we get 4 pi. So our period is 4 pi. Okay. There's no horizontal or vertical shift. So it's cosine. So from the origin, I'm going to start, since it's cosine, I start down 3. After the period, I'm back to down 3. So at 4 pi, I'm down 3. Halfway through, I'm up 3. Half of that, I'm at 0. Like that. So 1 period of this function looks like this. And now I just continue that pattern. On the right and on the left. Okay. Again, no arrows on those. You don't want to be misleading in your graph. It's not going to infinity and negative infinity. All right. Okay, so that's period and period and amplitude. Remember, amplitude is a vertical dilation and the period is a horizontal dilation. Now let's talk about translations. Let's talk about shifting. Okay, a horizontal translation is called a phase shift. When we're talking about trig functions, it's called a phase shift. Okay? So be used to both of those. Same meaning. Get used to seeing them both. These are shifts in the horizontal direction. So you have something being added or subtracted from your x in your argument. Okay? So you're going to shift your center, the origin, to the left c units if c is positive, and to the right c units if c is negative, just like we always have with our parent functions. Vertical translations, shifts in the vertical direction, up or down. If this is a number being added or subtracted from your entire trig function, shifts it up if c is positive, down if c is negative. This is a big tip for me. Put a plus sign on your what I call the new origin, and then use a dashed line. Draw a dashed line to indicate your new middle line. Okay? So let's graph sine of x minus pi over 4 plus 2. The amplitude is just 1. The period, the x coefficient is just a 1, so the period is just 2 pi. No change in period, no change in amplitude on this one. I'm going to start it easy. Phase shift, that's a horizontal shift. The phase shift is pi over 4 to the right. So right, pi over 4. Vertical shift, up 2. So our new origin is pi over 4, 2. Pi over 4, 2, and I put a plus sign right there. And then I draw a dashed line at my new middle. My middle was the x-axis, but my new middle is y is equal to 2. So y is equal to 2, that's my new middle. It extends from our new origin. Okay, so now we're thinking of that as my new origin. Sine starts at the origin and then goes up to its amplitude, high, and then back to the origin, and then down, and then back to the origin. Okay? So here's one period of this function. It's one period. And then once again, we extend it. And we keep on going on the other side as well. Okay. Alrighty. Let's do another one. Okay. Here we have a cosine. It has a new amplitude, it has a new period, it has a phase shift, it has a vertical shift. The amplitude is 3. The period is the period of cosine divided by the coefficient, the x coefficient. If you multiply top and bottom by 4, you'll get 8 pi over pi, so this is just pi. Now for the phase shift. Okay, so the phase shift is to the left 1, and the vertical shift is down 2. That makes our new origin -1, -2, -1, -2. And our new middle line, y is -2, so I just draw my dashed line there. Every time. Helps the graph, helps you see the graph. Okay, cosine, positive cosine. starts above the origin, whatever the amplitude is. So we start up 3 units from our new origin. Okay? Now, after 8 units, we're back here. After 8 units, we're back there. Okay? Halfway, we're down the amplitude. So we're down 3 from our middle line. Half of that, we're at 0. So 1 period of this function looks like that. And then to get the others, we keep on going with that pattern. Ooh, I kind of wish I had done this on the notes. Made the first period a different color than the rest of it. Oh well. I do like that. Oh, that would have been good. I might have to redo my notes because I like that effect. I like having that first one you draw a different color from the others. But anyway, okay. All right, another one. This time we have a -3 cosine. -3 cosine. So we'll have to keep that in mind. Negative. So it's going to be a reflection over the x-axis. Okay. Amplitude is 3. Period. Well, the period is the normal period for cosine divided by the x coefficient, and the x coefficient is 2, so the period is pi. Phase shift. We need to be super careful here because this is not in a form where we can see the phase shift yet. Because of the 2x, the phase shift is definitely not going to be pi over 2 units to the right. Okay? We need to take this and factor out a 2 first. Let's factor out a 2 first. When we factor out a 2, what do you multiply 2 by to get pi over 2? You multiply 2 by pi over 4 to get pi over 2. So 2x minus pi over 2 is 2 times x minus pi over 4. The phase shift is to the right pi over 4, not pi over 2. Vertical shift, down 3. Okay, so our new origin is positive pi over 4, -3, and our new middle is y is equal to -3. Okay, so new origin, pi over 4, -3, and then I draw my dashed line. Okay, -3 for cosine. -3 for cosine means I'm starting down 3 from my origin. Okay. After my period, I'm back to -3. So after pi units, I'd be at 5 pi over 4. I'm back to -3. It's cosine, so halfway across my period, I'm up at my maximum in this case. So up 3. And then halfway between those, I'm at 0. So 1 period looks like that. And then we can continue that pattern to get the rest of this graph. Oops, made that curvy down there. There are no cusps on these graphs at all. No cusps. All smooth curves. Alrighty. A couple more here. Alright, let's do a tangent. Okay, fortunately it's already in the formula. We can see the phase shift and all that. So the tangent does not have amplitude. Instead, you just call it a vertical dilation. The vertical dilation is 2. Okay. The period. Well, the normal period for tangent is not 2 pi, it's pi. Normal period is pi. I divide by the x coefficient, multiply top and bottom by 8, and we get 8. The phase shift is to the right 1. The vertical shift is down 2. New origin, positive 1, negative 2. New middle line, y equals negative 2. No parentheses. Okay. 1, negative 2 is our new origin. And then our new middle line. Okay. So, this is a tangent. In a tangent, its normal period is pi, right? And it's normal, the normal thing that we start with for tangent is our two asymptotes from negative pi over 2 and pi over 2. That's what I want you to think of as, just think of that first arm of tangent, regular old tangent. That's if the period is pi. Our period is 8. So if it's pi, we go from negative pi over 2 to pi over 2. So if it's 8, we'll go from negative 4 to 4. So from my origin, negative 4 and 4 are going to be my asymptotes. Okay, I keep getting interrupted. I'm taking care of the bunny and he keeps wanting me to rub him, to pet him. Anyway, okay, where were we? Alright, so we just did our first asymptotes. So I'm going to continue, I'm going to draw the rest of my asymptote. Oh, I might just draw my curve first. Okay, we have a tangent. It's tangent, right? Sorry. We have a tangent. The amplitude is 2. Not the amplitude. The vertical dilation is 2. Normally for tangent, from the origin, halfway between the origin and the asymptotes, halfway we would go up 1 and down 1. That's normal for tangent. If it was a negative tangent, they'd flip. Okay? But with the amplitude being 2, instead of going up 1, we go up 2 and down 2. So that one arm does that. It's a little awkward because of the way the units are here, but that's what it is. Okay, let's do our other leg. This is the first arm, the first period, one period of this curve. Okay, so 8 units away from 5, we'd have another vertical asymptote. Halfway through, we're at the origin. We'll do these 2 and negative 2 again. Does that? I really don't have much to work with, much space to work with here, so I'll just do that. Over on this side, another vertical asymptote. Halfway through, we're at 0, and then 2 and negative 2. That. Okay. Alright, let's do a secant. So I know secant are the one, that's one of the ones with the u's. It's the reciprocal of cosine. So everywhere that cosine is 0, secant will be that cosine value. Okay? And secant has asymptotes, vertical asymptotes, wherever cosine is 0. Hopefully I said that right. Okay. So, vertical dilation. Vertical dilation here is the 2. It's a factor 2. the period. The normal period for secant is the same as the period of cosine, and that is 2 pi. I'm dividing it by 1/2, multiply top and bottom by 2, and we get 4 pi. So the period here is 4 pi. Phase shift, right pi. Vertical shift, up 1. New origin is positive pi, positive 1. New middle, y equals positive 1. Don't know why I made that a negative. Positive 1. So new origin is pi 1. So pi 1, my new origin, and then I do my dashed line. So I'm envisioning secant. Secant is the one with all the u's, right? All the u's. Okay? Now, at the origin, cosine usually starts up, right? Well, that's exactly where secant will start. But instead of going up 1, we need to go up 2. Okay? After the period, we'll be back there. So after 4 pi, we'll be back there. Okay? Halfway through, we're at negative. The negative amplitude, not amplitude, vertical dilation for secant. Okay? And then halfway between those, that's where we have our vertical asymptotes. So vertical asymptote here and here. That means we have a vertical asymptote right on the y-axis, and another there, and here is there's one period, and then we can keep on going and draw lots and lots more. Okay? All right. Very good. Okay, one more example. The graph below is not the graph of which of the following functions? And I have all of these equations. This graph is not which one of these? Well, let's take it apart. Let's start with this sine. Here I see sine, the regular sine graph with an amplitude of 3, just shifted down 1. So shifted down 1, is this sine with amplitude 3? Yes, it is. That one works. Here it's cosine shifted right pi over 2, right pi over 2 and down 1. Right pi over 2 and down 1. Is that cosine with amplitude 3? It sure is. That's cosine with amplitude 3. Okay, the next one. Negative pi, it's a cosine shifted negative pi over 2 down 1, but it's a negative 3. Sorry, negative pi over 2 down 1, it's a negative 3. So if it's a negative 3, it should start down 3 and then be a cosine, and it is. Okay, what about this one? Negative 3 sine of this one, shifted to the left pi over 3, down 1. Is that a negative 3 sine curve? It is a negative 3 sine curve. All of the above have this as their graph. All of them have that as their graph. Okay, in class we might have time to do a few more examples. I might pull kids to the board, let them graph some. but this was transformations of the trig function graphs.